Night, you gaze into the boundless starry sky and feel a slight tremor. There, in the sea of stars, someone's life might be hiding. Is there anyone who is also looking at their sky right now and thinking about us? Generations of people have asked themselves this question. We dream of not being alone. We send signals into space and listen to the silence of the universe, hoping to hear at least an echo of another mind. But so far, nothing. Why can't we see any fellow intelligent beings anywhere? Where are all the aliens? It's a mystery that both excites and frightens. Today we'll embark on a journey through this enigma. We'll recall our attempts to reach out to the stars, learn about modern searches and scientific hypotheses, and imagine what first contact might be like. And perhaps, somewhere near the end, we'll return to the mysterious wow signal that once made us freeze with hope. Mankind has long not only dreamed about meeting aliens, but has also tried to start a conversation. At the height of the space race, Soviet scientists sent a simple radio message in Morse code in 1962, the words "Peace, Lenin, USSR," toward Venus. Although no aliens were found on Venus, this was a symbolic beginning. 1974, Arecibo Observatory, Puerto Rico. The huge dish of the radio telescope is aimed at the sky. Scientists freeze in anticipation. 3, 2, 1, launch. And a powerful radio pulse races into the depths of the galaxy. Thus was sent the famous Arecibo message, the first targeted cosmic address from humanity in history. The 169-second signal flew toward the globular star cluster M13, about 25,000 light-years away. It encoded simple images, numbers, chemical elements, the DNA spiral, a human figure, a diagram of the solar system, and the telescope itself, a kind of hello from our planet. This radio letter to the stars will arrive only after 25,000 years. Who knows? Perhaps then someone will receive and understand it. Also in the 1970s, we sent messages that were more literal. 1977. 2 spacecraft, Voyager 1 and Voyager 2, launch into space. Scientists attached gold-plated metal records to them, the actual golden records of Voyager. On these records are sounds and images of Earth. The noise of wind, bird songs, music by Bach and Chuck Berry, greetings in 55 languages. This is our message in a bottle for the great cosmic ocean. The Voyagers are heading beyond the solar system, carrying these messages into interstellar space. If someday, even 1,000,000 years from now, another civilization picks them up, it will learn what we were like. Parallel to sending messages, we also began to listen. In 1960, astronomer Frank Drake conducted the first scientific experiment to search for signals from fellow intelligent beings, Project Ozma. He monitored radio waves from 2 neighboring stars, Epsilon Eridani and Tau Ceti, at a frequency of 1,420 MHz, hoping to catch artificial transmissions. Nothing was found then. But this laid the foundation for a great endeavor. Thus was born the SETI program, Search for Extraterrestrial Intelligence. Radio telescopes around the world have been listening to space on different frequencies for decades, searching for a signal that could not appear by chance. We catch any whisper of stars that might turn out to be a cosmic hello. There have been false alarms, interference, signals from pulsars, or from Earth-based technology, which were initially taken for the real thing. But no credible alien message has been heard so far. Despite this, people don't give up. We continue to listen to the heavens, hoping that the silence will soon be broken. Today, technology has made a huge leap forward. Now we search for signs of life not only in the radio waves, we look for them in distant worlds. Over the past few decades, astronomers have discovered more than 5,000 exoplanets, planets orbiting other stars. We've learned to find even small Earth-sized planets orbiting in the habitable zone, at such a distance from their star where liquid water is possible. Among thousands of discovered worlds, dozens are potentially suitable for life, with conditions similar to Earth's. Now that we know there are countless planets like ours, the question arises, do they have atmospheres, and is there life there? Scientists have learned to analyze the faint light passing through a distant exoplanet's atmosphere and search for biosignatures, chemical traces of life. These could be gases like oxygen, methane, or ozone, which on Earth are produced by living organisms. Recently, for example, in the atmosphere of exoplanet K218b, scientists found a hint of dimethyl sulfide, a gas which on Earth is produced only by living creatures. So far these are only preliminary data, but the very fact of such findings is impressive. For the first time in history we can indirectly detect life on a planet without ever visiting it. All these years, SETI continued, but mostly quietly and with limited resources. The situation changed in 2015 when the Breakthrough Listen initiative was launched, the most extensive project to date for searching for alien signals. Philanthropist Yuri Milner and physicist Stephen Hawking announced the allocation of $100 million for a 10-year program of listening to the sky. As part of Breakthrough Listen, radio telescopes plan to scan in detail 1 million stars closest to Earth, the center of our galaxy, and even 100 nearest galaxies. An unprecedented amount of work. Computers automatically sort through millions of frequencies in search of anomalies. One of the recent results was the signal candidate BLC-1, detected in 2020 from the direction of Proxima Centauri, which initially created a stir, although later it was explained as being of terrestrial origin. A failure? No, rather a rehearsal before a real discovery. Breakthrough Listen continues, analyzing mountains of data. Perhaps soon, in one of them will emerge that very artificial melody from distant intelligent beings. So we send messages and listen carefully, and yet space is silent. The great silence reigns around us. Once, in 1950, the Italian-American physicist Enrico Fermi was discussing with colleagues a cartoon about aliens stealing trash cans in New York. Suddenly, amid the lively jokes, Fermi unexpectedly asked, "But where are all the aliens?" Silence fell. The question was humorous, but it hid a deep kernel of truth. If the universe is so old and enormous, if there are countless stars and planets, then why haven't we seen traces of other civilizations anywhere yet? The Fermi paradox lies precisely in this striking contradiction. On one hand, there are billions of stars around us, many older than the Sun, and potentially with life-bearing planets. On the other hand, not a hint that anyone is out there. No alien ships, no probes, no radio signals, absolutely nothing. Just think, our galaxy has about 300 billion stars, and there are also hundreds of billions of galaxies in the observable universe. Statistics say somewhere there must be life and intelligence. Moreover, Earth is not the oldest. It formed approximately 9 billion years after the Big Bang. So other planets could have appeared much earlier and theoretically given rise to civilizations millions or even billions of years older than ours. If evolution took the path toward intelligence on even a few of the multitude of worlds, where are these wise elder brothers? Why haven't they created a galactic federation, a star fleet? Why don't they travel between stars, as in science fiction films? Why don't their ships land in our fields? And why don't their signals fill the airwaves? The Fermi paradox has troubled scientists and science fiction writers for decades. Dozens of hypotheses have been proposed to explain the Great Silence. Let's consider some of them, from the most optimistic to the most disturbing. One possible answer to the Fermi paradox is the Great Filter hypothesis. It was proposed in 1996 by economist Robin Hanson. The idea is this: on the path of the emergence and development of life to the level of an interstellar civilization, there is an extremely difficult barrier. Perhaps almost no one can overcome this critical stage of evolution. That very filter screens out most embryonic civilizations. What is this barrier? It could be natural, for instance, catastrophic events on a planet, giant meteorites, deadly gamma-ray bursts may regularly destroy life, barely giving it a chance to emerge. Or it could be man-made, when life itself reaches a level at which it destroys itself. Nuclear war, uncontrolled climate change, creation of deadly technologies. In any case, the result is the same. Universal spaces remain quiet because almost no one passes this deadly qualifying selection, the Great Filter. However, the Great Filter can have different implications for us. Paradoxically, in an optimistic scenario, this explains our uniqueness. There is a version that the Great Filter cut off most chances for life long ago, and we are among the few, perhaps even the first lucky ones who managed to bypass it. Perhaps the universe is simply still young for intelligent life. There are interesting calculations. When Earth formed 4.6 billion years ago, only 8% of potentially habitable planets existed. The other 92% had not yet been born. This means that most possible cradles of life in the galaxy will appear after us. If this is true, then it's not surprising that it's quiet around. We're ahead of others. We are the early birds of the cosmos, lucky with our conditions. The Great Filter is somewhere behind us. We've passed it, while other worlds either haven't achieved complex life or perished before reaching our level. In that case, we humans are incredibly special. The only ones who can now survey the universe with understanding. On one hand, it's inspiring to be the chosen ones who broke through. On the other hand, it's frightening to be alone before the grandeur of the cosmos. Another scenario of the Great Filter hypothesis is quite gloomy. It suggests that perhaps life isn't so rare and emerges frequently, but none progresses too far because the final barrier lies ahead. This means all civilizations, upon reaching a certain level of development, quickly self-destruct or perish from cataclysms. The Great Filter is ahead of us, and we too are moving toward it. It's like cosmic natural selection. Only a few, possibly none, make it into the galactic club of long livers. If this is true, the silence around us is a bad sign. It means our chances are also questionable. Perhaps we're one step away from extinction, just unaware of it. Nuclear war, global pandemic, or technology spiraling out of control. The Great Filter can take various forms. In the science fiction parable, The Three-Body Problem, writer Luke Sixin described a world where an alien civilization experienced cyclical apocalypses. Their unstable three-star system repeatedly destroyed almost all life, with only the most adapted surviving to start development anew. This is a fictional example, but its striking intelligence can emerge and fade many times without ever reaching the stars. And perhaps, this is our fate too. The Great Filter, as a relentless judge, has not yet let anyone pass, and we are no exception. There's another possibility where the Great Filter is the emergence of life itself. Then we've already overcome the hardest part. Perhaps the genesis of even the simplest life is such an improbable event that it happened only once among billions of stars. In that case, we aren't just the first. We're alone. The rare Earth hypothesis, for example, states that too many fortunate circumstances aligned for our life to develop to be repeated elsewhere. The right star, the distance to it, a giant Jupiter shielding us from asteroids, a large moon, a magnetic field. Change just one thing, and humans wouldn't exist. Therefore, perhaps there is no other intelligence, because the conditions that created it almost never materialize anywhere else. The Great Filter hypothesis prompts us to consider if we are special. What a responsible position that is. And if the filter is ahead, how do we avoid the sad fate of all others? For now, these are just theories. No one has proven either the existence of such a filter or its absence. But this hypothesis compels humanity to value its chance and be careful with its own planet and technologies. Let's consider another explanation. Perhaps civilizations exist, but they deliberately remain silent. One of the most interesting ideas here is the zoo hypothesis. It was proposed in 1973 by astrophysicist John Allen Ball specifically as a response to Fermi's paradox. In short, we're under supervision, but they don't contact us. Intelligent aliens may have known about Earth and humans for a long time, but deliberately avoid any interaction. Why? They treat us like we treat wild animals in a reserve or zoo. They observe, study, perhaps even protect, but don't interfere. For them, we're a young species that should develop naturally. Imagine for a moment, somewhere out there, at the edge of the solar system, an undetectable alien probe is hiding, transmitting images of our world to distant planets. On that far-off planet, school children watch the Earth webcam in class, seeing how primitive humans live, and their scientists write dissertations about our culture. This is joking, of course. But the essence of the hypothesis is serious. If aliens are significantly ahead of us, it would be easy for them to remain invisible. They might believe it's better for us. Just as we don't interfere with an anthill except to observe, they keep their distance. This explains why we don't hear signals. We're simply isolated from external information noise for now. Ball pointed out that such an idea is psychologically unpleasant for us. Indeed, who wants to realize that we're an exhibit, animals under a dome, cared for by higher beings? It's a blow to our pride. But, as he noted, the history of science knows many examples where unpleasant hypotheses turned out to be true. Well, at least in this story we're alive. We haven't been destroyed or conquered. So aliens, if they exist, are peacefully inclined. Perhaps they adhere to strict cosmic etiquette. Don't disturb young civilizations until they mature enough for contact. When will we be released from the zoo? Perhaps one day, when we reach a certain level of development or make some sign, for example, start colonizing other planets or peacefully solve global problems, our curators will decide it's time to lift the veil. Then we'll officially receive first contact. Some variations of this hypothesis allow that contact happened earlier, but at the level of isolated incidents, not en masse, hence all the UFO legends, possibly. However, until there's direct evidence, the zoo hypothesis remains unverified. By its logic, proving it is almost impossible, because any of our attempts to find extraterrestrial life would be artificially blocked by the zoo keepers. It turns out, if this is true, we'll learn about others only when they want us to. This hypothesis, like the dark forest hypothesis which we'll discuss shortly, paints a not very cheerful picture. We're under constant surveillance, but powerless to change anything. However, you must agree, there's also a ray of hope in it. If we're consciously protected, it means we're not alone. Somewhere out there are those who also traveled the path from a small creature to superintelligence, and now watch over newcomers. Perhaps someday we'll join their club. But for now, space is silent, and this silence may be intentional. Considering all this, humanity faces a difficult question: to listen or to speak. We've already talked about our messages. These were more symbolic acts. Currently, there are debates among scientists. Should we actively send new signals into space, trying to attract the attention of possible cosmic brothers? This direction has even received a separate name: METI, Messaging Extraterrestrial Intelligence, as opposed to passive SETI. Some, like Ukrainian-American astronomer Alexander Zaitsev, passionately support this idea. He said, "Our civilization should emerge from the great silence and tell our neighbors, you are not alone." METI proponents believe that if everyone sits quietly, contact will never happen. Someone has to take the first step. However, others, including the famous physicist Stephen Hawking, warn shouting across the cosmos might be dangerous. Look at history, Hawking noted. Contacts between civilizations with different levels of development ended badly for the less developed. He meant the example of Columbus and the indigenous peoples of America. Those encounters turned catastrophic for the latter. If we announce ourselves, and the signal is heard by someone significantly ahead of us, their attitude toward us might be like ours toward bacteria. They might not even consider us worthy of communication, or worse, colonize, exploit, or destroy us. Seeing a threat. Hawking compared such a situation to a dark forest, where everyone fears revealing their position, lest they be killed. The dark forest hypothesis from Lou Sixon's novel states, if there's even one aggressive civilization in the universe, all others are forced to remain quiet, like in a dark forest, to avoid attracting the predator's attention. So, perhaps, space is silent precisely because all intelligent species are hiding. Our planet is already revealing its existence. Radio signals from television and radar have been leaking into space for 100 years. If someone nearby is listening, they could theoretically have already detected us. Perhaps someone is already coming to our signal. This thought is exciting. This is fantasy, of course, but the scientific community really does face a moral dilemma. Do we have the right to expose all of humanity to potential risk by shouting into the ether about our existence? So far, there's no official ban, but most major messages are internationally coordinated. There were precedents in 2017 to 2018. Enthusiasts sent several signals to nearby stars in the direction of the red dwarf Luton star and others, small messages with information about humans. This sparked discussions. Some said, "We'll never find anyone if we aren't active." Others responded, "What if we bring trouble upon ourselves?" So far, most agree with Hawking's strategy. Let's listen, but not reveal ourselves. At least until we better understand who might be receiving our signals. Perhaps one day, when we detect reliable signs of life on some planet, humanity will collectively decide to send greetings there. But this will be a decision of all humanity, not individual enthusiasts. That's what many scientists believe. The price of a mistake here is too high. But imagine that one day contact happens. What might it be like? History and science fiction paint many scenarios, from bright to eerie. Let's consider a few based on both science and our imagination. 1. We hear a signal. Most likely, first contact will happen at a distance, through radio or optical signal. Imagine on a quiet night, an unusual signal appears on a computer screen in an observatory. At first, barely noticeable, but the algorithm alarmingly highlights it among the noise. Astronomers gather, reconfigure telescopes, and here's confirmation: it's an artificial interstellar signal. They exist. We're not alone. One researcher shouts with joy, others applaud with tears in their eyes. Humanity will remember this moment forever. Most likely, it will be something like a series of simple numbers or pi, or an encoded image, because aliens would probably first try to get our attention with something unmistakably artificial. Then, years of deciphering and correspondence. Between stars, enormous distances, so exchanging messages might take years, even centuries, if the signal came from, say, 100 light years away. That's okay. The main thing is, we know they exist. This scenario is optimistic and peaceful. Contact happens on our terms, remotely. We have time to prepare, consider responses. Perhaps this correspondence will last generations, and someday our descendants will actually meet the addressees physically. But this is the beginning of a great cosmic friendship. 2. They find us first. Another possibility, we receive a signal, but the initiative comes from the other side. For example, a powerful beam from a nearby star hits our radio telescopes, someone is deliberately calling us, or even an automatic interstellar station arrives, similar to how we send probes to Mars, only coming to us from another planet. It could be an incredibly intelligent artificial intelligence, an ambassador who traveled through the abyss for decades. Imagine astronomers detect a mysterious object in Earth's orbit. At first they think it's an asteroid, then space debris, but it begins to slow down and enters a stable orbit. Panic? Impression? Joy? All feelings together. Humanity is alarmed. We no longer control the situation. We're left waiting to hear what the visitor will say. And then, it depends on luck. Perhaps it will transmit a message to the entire planet. For example, demonstrate some symbol or sound understandable without words to show peaceful intentions. Perhaps even help us share knowledge or technologies. But there's also a risk. If they're here, and we're absolutely powerless before their level, then our fate is in their hands. Let's hope the aliens prove wise and benevolent. 3. A civilization visit, zero-level contact. This is the most dramatic and honestly unlikely scenario in the near future, aliens arriving on Earth. If one day alien ships hover in the sky, the world will change instantly and forever. Peaceful visit. They land. Establish contact, possibly through a translator, and offer to join the Galactic Commonwealth. A new era will dawn for humanity. Technology exchange, disease curing, travel to the stars. Of course, there will be cultural shock, rewriting of all textbooks, and possibly loss of part of our identity. But such an alliance would bring us many benefits. Hostile visit. If their goal is conquest or resources, hard times await us. Like bugs before a shoe. That's how we might look to aggressive aliens. Chances of fighting back are slim, though in movies we always win. Let's hope that space invaders are just a Hollywood invention. Misunderstanding. There's also an interesting possibility that contact will be neither friendly nor entirely hostile, but rather unsuccessful due to misunderstanding. Beings arrived, but we couldn't establish communication. Their language, appearance, way of thinking differ so much that neither side perceived the other as intelligent. The most realistic first contact seems to be distant signal exchange. This is confirmed at scientific SETI conferences. It will be slow, but safe, and it could, by the way, already be happening. Because possibly, we received the first message back in 1977, we're just not sure about it yet. On August 15, 1977, the Big Ear radio telescope in Ohio, USA, was catching cosmic radio waves, as usual, as part of the SETI program. Nothing special. And suddenly, a sharp signal spike. The data ran to the computer printout. Astronomer Jerry Amon, on duty that night, saw a row of values on the printout. 6 EQJ5. This was the intensity code of the received signal. It meant that the telescope had registered an ultra-powerful narrowband radio signal at approximately 1420 MHz frequency, the hydrogen line from the direction of the Sagittarius constellation. The signal lasted 72 seconds. the maximum time Big Ear could observe a section of the sky. The impressed scientist circled these symbols with a pen and wrote "Wow" in the margin. That's how this phenomenon entered history, as the wow signal. To this day, it's probably the most mysterious signal we've ever received from space. What was it? Immediately, the extraterrestrial origin theory emerged. After all, the 1420 MHz frequency is very canonical for SETI. It's the frequency of atomic hydrogen radiation, a universal beacon. The signal was strong, narrow, like from a transmitter, and bore no signs of a natural source like a pulsar or an echo from an Earth satellite. Unfortunately, it was never recorded again, though this area of the sky has been examined many more times. The wow signal remained a one-time mystery. So far, space has answered us only with the mysterious wow, as if teasing, yes, perhaps, one day we'll solve this mystery. Until then, let's not stop looking at the stars and asking, where are you? Or perhaps more quietly, because someone might be out there, listening to us in return.